Hello students, I am your Aishwarya and this is Sankalpa Learning Classes. Welcome to the session 3 of Coordination Chemistry. So here we'll be discussing some forwarded chapters or concepts regarding coordination chemistry. Yen discuss ಮಾಡ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ basically here we'll be talking about isomerism which is seen in coordination compounds, and we'll be talking about the different theories which are used to explain the concepts of coordination compounds. So isomerism anta andre ಏನು? What do we mean by isomerism? See, this term we have used in PU1, but we have seen it in organic chemistry, alva. Organic chemistry alli ನಾವು ನೋಡಿದೀವಿ different types of isomerism shown by different organic compounds. Same thing we are going to discuss here, but in a different way. So here we are going to talk about isomerism in coordination compounds. Coordination compounds alli yav tarada isomerism agatte and what are the different types we are going to see here. So isomerism antandre enu? So what do we mean by isomerism? The compounds having the same molecular formula but different structures are called isomers. Am I right? So compounds, they possess compounds with the same molecular formula, molecular formula ಅಂತಂದ್ರೆ ಏನು ಹೇಳಬೇಕಾಗಿಲ್ಲ. They have same molecular formula, two or more compounds having the same molecular formula but differ in properties ಅಂತ ಅನ್ಬೋದು. Different properties are called isomers. Yes, they are called isomers and the phenomena is called as isomerism. The phenomena is termed as isomerism. Idu isomerism alli we have different types of isomerisms. So which are the types of isomerisms andaga? See, we start with the first point, that is isomerism is basically divided into two types. It is basically divided into two types. What are those two types? Here we have the two types of isomerisms. One is structural isomerism. And the other one is stereoisomerism. ಹೌದಾ? ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಕೂಡ ಇದನ್ನೇ ನೋಡ್ತೀವಿ ನಾವು, ಹೌದಾ? ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮೆರಿಸಮ್ and another one is the stereoisomerism. Now the question is, what is structural isomerism and what is stereoisomerism? Then we can understand the types of structural and stereoisomerisms. Structural isomerism definition goes the same. ಏನಪ್ಪ structural isomerism ಅಂತ ಅಂದ್ರೆ, these are the compounds having same molecular formula, compounds with same molecular formula but different structures. They have different structural representations. ಅಥವಾ ಇಲ್ಲಿ ನಾವು coordination compounds ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ಬೋದು ಅಂತಂದ್ರೆ, compounds having the same molecular formula but differ in arrangement ಅಂತ ಹೇಳ್ಬೋದು. So I can say different arrangement of ligands. Where? Around the central metal atom. So central metal atom suttu arrangement of ligands hegide depending on that we have structural isomers, and these structural isomers are further classified. Hegeppa classify ಮಾಡ್ತೀವಿ? They are classified as a ionization isomerism, linkage isomerism, coordination isomerism, hydrate isomerism. We will be studying them one by one. One example ತಗೊಂಡ್ಬಿಟ್ಟು what does that mean ಅಂತ ನೋಡೋಣ. What is stereoisomerism? Stereo, even in organic chemistry we have seen. Stereo ಅಂತ ಅಂದ್ರೆ ಏನು? Stereo speaks of something about the spatial arrangement. Yes, so these are also compounds with same molecular formula. So compounds with same molecular formula. Molecular formula does not change. So compounds with same molecular formula but differ in not just arrangement, they differ in the spatial arrangement. Not special, spatial, that is in the space. Spatial arrangement of whom? Of ligands, or we can say of atoms or groups about the central metal atom. about the central metal atom. Correct? So this is two types of isomerisms, structural isomerism and stereoisomerism. Aita. Now this structural isomerism is divided into how many types I said? It is divided into 4 types. 1, 2, 3 and 4. Whereas stereoisomerism is divided only into 2 types. Yavavappa 4 types. So the 4 types of structural isomerisms are: one is ionization isomerism. Ionization isomerism. Second one is linkage isomerism. Linkage isomerism. Third one is coordination isomerism. Coordination isomerism. And last one is hydrate isomerism. Hydrate isomerism. This is isomerism. Isomerism. Okay. So these are the 4 types of structural isomerisms. Yes. ಹೇಗೆ coordination compounds ಅಲ್ಲಿ ನಾವು ಅಲ್ಲಿ ನೋಡಿದೀವಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ದ ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಐಸೋಮರ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ ಅಲ್ಲಿ ನೋಡಿದೀವಿ. ವಾಟ್ ಆರ್ ದ ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್? ಅಲ್ಲಿ ನಾವು ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ ಅಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಚೈನ್ ಐಸೋಮೆರಿಸಮ್, ಪೊಸಿಷನ್ ಐಸೋಮೆರಿಸಮ್, ಫಂಕ್ಷನಲ್ ಐಸೋಮೆರಿಸಮ್, ಮೆಟಾಮೆರಿಸಮ್, ಟಾಟಾಮೆರಿಸಮ್ ಇವೆಲ್ಲ ನೋಡಿದೀವಿ. ಅಲ್ಲಿ ಆ ಕಂಪೌಂಡ್ಸ್ ಗೆ those are the isomers. But here when we talk about coordination compounds, here we have different types of structural isomerisms. ಯಾವ್ಯಾವಪ್ಪ? ionization isomerism, linkage isomerism, coordination isomerism and hydrate isomerism. ಅದೇ ಈ ಸೈಡ್ ಬಂದ್ಬಿಟ್ಟು ಸ್ಟೀರಿಯೋ ಐಸೋಮೆರಿಸಮ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ಸ್ಟೀರಿಯೋ ಐಸೋಮೆರಿಸಮ್ there are 2 types of stereo isomerisms. ಯಾವ್ಯಾವಪ್ಪ? ಸೇಮ್. One is geometrical isomerism. Geometrical isomerism, which is also called as, come on, tell me, which is also called as what? Which is also called as cis-trans isomerism. Cis-trans isomerism. And the another one is optical isomerism. ಹೌದಾ? Optical isomerism. Stereoisomerism ಅಲ್ಲಿ changes ಇಲ್ಲ. So these are the 2 types of stereoisomerisms. So all these 6 types, we will study them one by one. So let us start with the first structural isomerism, that is ionization isomerism. So ionization isomerism anta andre ಏನು? What do you mean by ionization isomerism? So let me take it like this. I'll tell you the definition. We will take up with an example to understand the concept. So ionization isomerism anta endrenu? The coordination compound having same composition. ಅದರ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಅನ್ನೋ ಬದಲು ನಾನು ಏನಂತ ಇದ್ದೀನಿ, ಐ ಆಮ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ದಿ ಕಾಂಪೋಸಿಷನ್. ದಟ್ ಇಸ್ ಒನ್ ಅಟ್ ದ ಸೇಮ್ ಅಲ್ವಾ? ಸೊ ಹ್ಯಾವಿಂಗ್ ದ ಸೇಮ್ ಸ್ಟ್ರಕ್ಚರಲ್ having the same composition, or you can use that molecular formula, but gives different ions in the solution. Yes. So ionization isomerism means what? Yes, it is the structural isomerism. It is a type of structural isomerism. Howda? Yes, it is the type of structural isomerism in which compounds have, or you can use the term coordination compounds, have same molecular formula, ಅಥವಾ ನಾನು ಸೇಮ್ ಕಾಂಪೋಸಿಷನ್ ಅಂತಾನು ಅನ್ಬಹುದು. ಸೇಮ್ ಕಾಂಪೋಸಿಷನ್ but give different ions in the solution, are called ionization isomerism. Isomers, and this phenomenon is called ionization isomerism. Understood? They have same molecular formula, but they give different ions in the solution. ಈಗ ಡಿಫ್ರೆಂಟ್ ಅಯಾನ್ಸ್ ಯಾವಾಗ ಬರುತ್ತೆ ಹೇಳಿ? ವೆನ್ ದೇರ್ ಇಸ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಫ್ ಅಯಾನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಕೋಆರ್ಡಿನೇಷನ್ ಸ್ಪಿಯರ್ ಅಂಡ್ ದಿ ಅಯೋನೈಸೇಷನ್ ಸ್ಪಿಯರ್. I hope you remember what is coordination sphere and ionization sphere. For example, if I write like this, ಹೌದಾ, ಹಿಂಗೂ ಬರಿಬಹುದು. I'll tell you what do I mean by it. ಅಥವಾ ನಾನು ಹಿಂಗೂ ಬರಿಬಹುದು. Okay. So here, what is C standing for? I've taken C and A because C stands for cation, A stands for anion. So here, C is my cation, so it is outside, and this is my A anion with a negative charge. Howda? So this is what? This is my coordination sphere, and this is my ionization sphere. Howda? This is ionization sphere. This is what? In the square bracket, it is the coordination sphere. Come back this side. C, positive charge, A, negative charge. So this is positive ion is my coordination sphere, whereas negative ion is my ionization sphere. ಅರ್ಥ ಆಗ್ತಿದೆ ಅಲ್ಲ? So here what does this ionization isomerism is telling us is ಇಲ್ಲಿ there occurs exchange of ions. There is exchange of ions. Exchange of ions where ಯಾರ ನಡುವೆ exchange of ions ಆಗ್ತಿದೆ ಹೇಳಿ? Between the coordination sphere, between the coordination sphere and ionization sphere. Ionization sphere. Understanding? So coordination sphere ಮತ್ತು ionization sphere ನಡುವೆ there is exchange of the ions. Okay, let us take an example now to understand this. What example we can give? See, I'll take the example COBr NH3 5 times SO4. Yes, I can write this also as COSO4 NH3 5 times, and outside I'll write Br. So what is happening you can see here. Yes, let us try to write the name nomenclature for these two coordination compounds. Name hedi nodana. This is cation, this is anion. So here I write the name as pentamine, correct? Pentamine, bromo, cobalt, oxidation state ಬಂದ್ಬಿಟ್ಟು 3, sulfate. ಹೌದಾ? So this is the name. What is the name for this? This is pentamine, sulfate, sulfato, cobalt. Again, coordination number, oxidation number ಬಂದ್ಬಿಟ್ಟು 3. This is bromide. So look at the oxidation sphere and the ionization sphere. Illi this is oxidation sphere, this is ionization sphere. Illi this is oxidation coordination sphere, this is ionization sphere. Hauda? So ions idanna nanu solution alli hakidre, if I put this in the solution, ಯಾವುದು ions ಬರುತ್ತೆ ಹೇಳಿ ಇಲ್ಲಿ? SO4 minus 2, SO4 minus 2, sulfate ion is present in ionization sphere. It is present in ionization sphere. Howda? Ionization sphere. Here on the other side, which ion is present? Tell me. Br minus ion is present in ionization sphere. It is present in ionization sphere. Getting my point? So here, how do I understand? These are different types of isomers. Idana BaCl2 jote haki. Treat this particular compound with BaCl2. It will give me, since there is SO4 minus 2, it will give me white precipitate. So this gives white precipitate with BaCl2. ಅದನ್ನೇ ನೀವು ಇದನ್ನ BaCl2 ಜೊತೆ ಟ್ರೀಟ್ಮೆಂಟ್, ನೋ, ದಿಸ್ ವಿಲ್ ನಾಟ್ ಗಿವ್ ಯು ಎನಿ ವೈಟ್ ಪ್ರೆಸಿಪಿಟೇಟ್. ಇನ್ಸ್ಟೆಡ್ ಇಟ್ ಗಿವ್ಸ್ ಯು ಯೆಲ್ಲೋ, ಲೈಟ್ ಯೆಲ್ಲೋ ಅನ್ಬೋದು ಅಥವಾ ಪೇಲ್ ಯೆಲ್ಲೋ ಅನ್ಬೋದು. ಪೇಲ್ ಯೆಲ್ಲೋ ಪ್ರೆಸಿಪಿಟೇಟ್ ವಿತ್, can you tell me with which reagent? It gives pale yellow precipitate with AgNO3. Understanding? So these are the two examples which will help me tell what is ionization isomerism. So you can see here, both are having same composition. Molecular formula bandbittu same ide, but what is different? They are giving different ions in the solution antidare. Yaake different ions hedi? Because ionization sphere ಮತ್ತು coordination sphere ನಡುವೆ there is exchange of ions. Andre Br is coming into ionization sphere from the coordination sphere, and SO4 is getting into coordination sphere from the ionization sphere. That's the reason this particular first example is going to give me white precipitate with BaCl2, whereas the second example, since there is Br minus in the ionization sphere, if I treat it with AgNO3, it will give me pale yellow precipitate. So this is about the ionization isomerism, the first isomerism in structural isomerism. Coming to the second one, that is linkage isomerism. So what do I mean by linkage isomerism? So let us see the definition first. So ionization isomerism is clear. Yes. So linkage isomerism anta andre enu? What is linkage isomerism? Okay. The name itself tells. Yes. In this case, I can say what is happening. Tell me. In this case, linkage isomerism alli yenagate? It differs in the mode of attachment. differ in the mode of attachment of ligand to the central metal atom and the phenomenon is called what? The phenomenon is called linkage isomerism. The phenomenon is called linkage isomerism. For example, let us take one example to understand this. Okay, fine. So I will write the example CO. ಬರ್ದ ತಕ್ಷಣ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಬಿಡತ್ತೆ what we are talking about. ONO NH3 5 times Cl2. And here I'll write CO NO2 NH3 5 times Cl2. So you can see here, can you tell me the names for these compounds? What are the names? Heli nodona. Okay, so here it is pentamine, nitro O anta bariಬಹುದು, or I can write it as nitrito. ಬರಿಬಹುದಲ್ಲ? Yes, nitro O ಅಂತಾನು ಬರಿಬಹುದು, ಅಥವಾ you can write it as nitrito, cobalt 3 chloride. Correct? This side, what is the name? Tell me. It is pentamine, nitro, cobalt 3 chloride. ಹೌದಾ? ಸೊ ಅಯಾನ್ಸ್ ಎಕ್ಸ್ಚೇಂಜ್ ಆಗ್ತಿಲ್ಲ, ಬಟ್ ದ ಮೋಡ್ ಆಫ್ ಅಟ್ಯಾಚ್ಮೆಂಟ್. ಸೊ ಲಿಂಕೇಜ್ ಐಸೋಮೆರಿಸಮ್ ಯಾವಾಗ ಆಗತ್ತೆ ಹೇಳಿ? ಲುಕಿಂಗ್ ಅಟ್ ದ ಎಕ್ಸಾಂಪಲ್, ವಿ ಕ್ಯಾನ್ ಸೇ ವೆನ್ ಡಸ್ ಲಿಂಕೇಜ್ ಐಸೋಮೆರಿಸಮ್ ಕಮ್ ಇನ್ ಟು ಕಾಂಟೆಕ್ಸ್ಟ್? ಇಟ್ ಕಮ್ಸ್ ಇನ್ ಟು ಕಾಂಟೆಕ್ಸ್ಟ್ ಓನ್ಲಿ ಇನ್ ಕೇಸಸ್ ಆಫ್ what? Ambidentate ligands. Correct? It comes in context only in case of ambidentate ligands. We talk about linkage isomerism. ಹೌದಾ? So linkage isomerism ಅಲ್ಲಿ mode of attachment of the ligand, what is point of attachment of the ligand will be different. So here there will be one ambidentate ligand. ಅಲ್ಲಿ point of attachment ಬೇರೆ ಆಗಿರೋದ್ರಿಂದ it gives rise to two isomers, which we call them linkage isomers. So here O is the attacking point. Therefore, I can also write the, excuse me, I can also write here nitrito ಬರೆಯೋ ಬದಲು I can write it as nitro O ಅಂತ ಬರಿಬಹುದು. Here nitro ಅಂತ ಬರಿ ಬದಲು I can write it as nitro N. I can write it like this also. Fine. IUPAC nomenclature alli ನಾವು ನೋಡಿದೀವಿ. So here, what is the difference? Tell me. Molecular formula is same. Molecular formula is same. The difference here is the mode of attachment, the point of attachment of a ligand to central metal. Here the ligand is attacking through oxygen, and here the ligand is attacking through nitrogen. So such type of isomerism is called linkage isomerism. Coming to the third type of isomerism, that is coordination isomerism. So coordination isomerism anta andre ಏನು? What do we mean by coordination isomerism? So definition goes something like this. It is, they have, in this case, so I can write it like this. Compounds have same molecular formula but compound is made up of cation and anion, and isomerism arises due to interchange of ligands between complex cation and complex anion. Yes, big definition, but very simple to understand. So, ಏನ್ ಹೇಳತ್ತಪ್ಪ coordination isomerism? In this case, the compounds have same molecule for. Okay, fine. But the compound is made up of complex cation. Okay, here. The compound is made up of complex cation and complex anion. ನೋಡಿ ಎರಡು ಕ್ಯಾಟಯನ್ ಮತ್ತು ಆನಿಯನ್ earlier cases we have seen. See, if you see previous slides, you can see here either one of the ions is complex. ಇದು in this case the cation is complex. Howda, in certain cases the anion will be complex. But here we are talking coordination isomerism ಅಲ್ಲಿ ಯಾವಾಗ ಅರೈಸ್ ಆಗತ್ತೆ ಹೇಳಿ, when both the cations and anions are complex in nature. Both should be complex ions. They should be written in a square bracket ಅಂತ ಅನ್ಬಹುದು, ನೀವು ಹಂಗೆ ನೆನಪಿಟ್ಕೊಳ್ಬಹುದು. And when does this isomerism arise? It arises due to interchange of ligands. Ligands is position interchange ಆದಾಗ the between complex cation and anion, that time we have coordination isomerism. Let us see this with an example. So I will write, you have first example CONH3 6. This is my cation. Then CrCN6. This is my anion. Other case I can write it as CrNH3 6 COCN6. So you can see here. Can you tell me the name for this compound? Name ಹೇಳಿ ನೋಡೋಣ. How do you write the name? So here I can write it as hexamine, cobalt. Cation ಆಗಿದ್ರೆ we'll write it as cobalt only. The oxidation state ಬಂದ್ಬಿಟ್ಟು 3. Then hexacyanochromate 3. ಹೌದಾ? This is the name. This side, tell me the name. It is hexamine, chromium 3, hexacyanocobaltate, ನೋಡಿ, cobaltate 3. So this is the coordination isomerism. So what is happening here? Complex cation in the first case contains NH3 ligand with cobalt, and complex anion contains CN with Cr. In the second case, complex cation contains NH3 with Cr. Here NH3 with CO, here NH3 with Cr. And complex anion is containing Cn with CO. So there is interchange of the ligands between the complex cation and the complex anion. ಎರಡು complex ಇದ್ದಾಗಲೇ we have coordination isomerism. So this is about coordination isomerism. Coming to the fourth type of isomerism, that is hydrate isomerism. Hydrate isomerism. This is also called as solvate isomerism. It is also called as solvate isomerism. Okay. So what is this hydrate isomerism now? Hydrate isomerism yadakantivi. Hydrate is the term related with water. Howda? It is the term related with water. So how do you write the definition? Let us see. Hydrate isomers. These isomers, I can write it like this, have same composition, same molecular formula, same composition, but differ in the number of ಏನು hydrate ಅಂದ್ರೆ differ in the number of water molecules present as ligands and outside also. Okay, so this is hydrate isomerism. Same composition ಇದೆ, number of water molecules are different. ಏನಪ್ಪ ಹಿಂಗಂದ್ರೆ, let us see with an example. So let us take the example here. I'll write CrH2O6 Cl3. Okay, I can write this compound also as CrH2O5 Cl2 dot H2O, or I can write it also as H2O4 Cl2 Cl 2H2O, or I can write it also as Cr. Okay, Cl is outside, right? Chloride is outside. Let us take it up to here. So if you write the name for these compounds, can you tell me the names? Names heli nodana. So this compound, the name will be hexa aqua chromium 3 chloride. Howda? Chromium 3 chloride. Okay. Tell me the name for this. It is penta aqua okay. Then Cl also is there as a ligand. So I'll write it as chloro, then chromium 3 chloride, 1 water anta baribahudu, athwa I can write it as monohydrate. Then what is the name for this? I can write it as tetra aqua dichloro chromium 3 chloride dihydrate. Yes. So these are the different isomers where molecular formula is same. Nodri, 6 water molecules are there. Here also 5 plus 1, 6 water molecules are there. Then 4 chromium is 1. Here also 4 plus 2, 6 water molecules. Chloride ions, 3 chloride ions, Cl2 and 1, 3. Cl2 and 1, 3. So composition is same, but they differ in the number of water molecules present at ligands. First case only, how many water molecules are there as ligands? In the first case, there are 6 water molecules as ligands. In the second case, there are only 5 water molecules as ligands. This is water crystallization outside the complex ion sphere. There are 4 water molecules as ligands. How the so coordination change aagta hogutte in comparison with water molecules I'm talking. Overall coordination is again 6. You can see here 6, 5 plus 1, 6, 4 plus 2, 6. How the even if you look at the colors of these compounds, if you look at the colors, the first one is violet in color. The first one is violet in color. Second one is blue-green in color. And the third one is dark green anbodu. This dark green in color. So this is the types of what you say structural isomerisms. So we have spoken about all the 4 types of structural isomerisms. So we had discussed the first one, that is ionization isomerism. I'm recapitulating it. Differ in they give different ions in the solution. So ions different agiratte. Don't get confused with coordination isomerism. Okay, ions ಬೇರೆ ಆಗಿರುತ್ತೆ. Coordination sphere ಏನಾಗ್ತಾ ಇದೆ actually ions exchange ಆಗ್ತಿದೆ coordination sphere ಮತ್ತು ionization sphere ಮಧ್ಯೆ. Okay, that is ionization isomerism, and therefore they different ions give different precipitates. ಯಾಕಂದ್ರೆ when you put it in the solution, it will dissociate like this. Dissociate ಆಗ್ತದೆ. So this is plus, this is minus 2. Yes, but here it is plus minus 1. So he dissociate adaga, sulfate ions are into the solution. They will give respective precipitate with respective reagent. Br minus in the solution, it will give respective precipitate with respective reagent. Okay, fine. Then we have studied linkage isomerism arises only in case of ambident ambident ligands. ಹಂಗಿದ್ದಾಗ ಮಾತ್ರ ಬರುತ್ತೆ, because the mode of attachment ಅಥವಾ point of attachment ಏನಾಗುತ್ತೆ vary ಆಗುತ್ತೆ. In some cases, one of the atom of the donor atom of the ligand will be attacking. In the other case, some other donor atom will be attacking, which gives rise to linkage isomerism. Then we have coordination isomerism. This arises only when both cation and anions are complex in nature. Both should be complex ions. Then only what happens between the ligands and the central metal, between the cation and anion, there is exchange of the ligands, interchange of the ligands anta anbodu. Because you can see here, in this case, in case of first example, if you see, what I can say is complex cation contains what? It contains NH3 ligand with cobalt. And complex anion, if you see complex anion, it contains what? It contains CN ligand with chromium. Whereas in the other case, here complex cation, you can see the difference, contains what? NH3 ligand with chromium. Whereas complex anion, look at the anion and tell me CN ligand with cobalt. Yes. So this is where we speak about coordination isomerism. Hydrate isomerism, water molecules. So ಹೀಗೆ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ ಆಯ್ತು. ಅಯೋನೈಸೇಷನ್ ಐಸೋಮೆರಿಸಮ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಅಯಾನ್ಸ್ ವೇರಿ ಆಗುತ್ತೆ. ಲಿಂಕೇಜ್ ಐಸೋಮೆರಿಸಮ್ ನಾಟ್ ಅ ಡಿಫಿಕಲ್ಟಿ. ಸೊ ಯು ಕ್ಯಾನ್ I'm sorry, linkage isomerism ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? It is arising only when you have ambidentate ligands. Coordination isomerism, both complex cation and anions should be complex ions, and hydrate isomerism when we talk about water molecules. Understanding? So our number of water molecules as the ligands differ. In the first case, there are 6 water molecules. In the second case, there are 5 water molecules because one comes outside and becomes water of crystallization. In the third case, there are 4 to come out as water of crystallization. Adardu coordination number balance madlike chloride ions are getting into as ligands. Hauda? So this is all about the structural isomerism. Now what we are going to talk about is we are going to talk about stereoisomerism. Stereoisomerism. So stereoisomerism anta andrenu we have already discussed. Same molecular formula but differ in the spatial arrangement of the atoms. They differ in spatial arrangement of the atoms or ligands around the central metal atom anta anbodu. So here the first one under stereoisomerism is geometrical isomerism. So geometrical isomerism we have, and I told you this geometrical isomerism is also called as cis-trans isomerism. Cis-trans isomerism. Now we have studied in organic chemistry ಅಲ್ಲಿ ನೋಡಿದ್ವಿ. Organic chemistry we have discussed cis-trans anta andrenu same side of the double bond. Same side of the double bond we call it as cis. On the opposite sides of the double bond we call it as trans. Here also it is something similar. Cis-trans anta antidivi andmele it is something similar. So let us try to understand what does that mean. Okay. So definition artha madkondu we'll see. So this isomerism arises. I'll write the definition here. This isomerism arises due to difference in geometrical arrangement of what? Of the ligands around the central metal atom. Around the central metal atom. So differ in the geometrical arrangement around the central metal atom andaga when identical ligands, I can also say it like this, I can also put it like this. Yenappa anbodu andre when identical ligands, when identical anta andre when same ligands, identical or same ligands occupy positions near to each other. Near to each other called cis isomer. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ? We call it as cis isomer. Okay. I'll write it here. Cis isomer. Okay. Second point, when identical ligands occupy positions opposite to each other. Is called trans isomers. Yes, they are called trans. Idu almost same anta helide nanu. Trans isomers. Something same alva. So let us try to understand this with an example. Example ತಗೊಂಡ್ಬಿಟ್ಟು ಮಾತಾಡೋಣ. So cis trisomer ಅಂದ್ರೆ ಏನು? When they occupy same positions. So it is very common in disubstituted complexes ಅಂತ ಅನ್ಬೋದು with coordination numbers 4 or 6. So coordination number ಬಂದ್ಬಿಟ್ಟು 4 ಇದ್ದಾಗ or it might be 6 or ಅನ್ನೋದಕ್ಕಿಂತ coordination number 4 ಮತ್ತು 6 ಎರಡು ಇದ್ದಾಗ we talk about geometrical isomerism. 4 and 6 ಅಂತ ಯೂಸ್ ಮಾಡ್ಬೋದು ನನ್ನ ಟರ್ಮ್. ಹೌದಾ? So let us take an example with coordination number 4. So coordination number 4 ಇದ್ದಾಗ if I have a central metal atom here and these are attached to ligands ಅಂತ ಅನ್ಬೋದು. ಹೌದಾ? So this will give rise to square planar complex. ಹೌದಲ್ವಾ? Yes. Okay, let me make it like this. Put it in a very proper form. Correct? So here we have metal atom. Okay. Right? So here I will number it like this. 1, 2, 3, and 4. So if I'm talking about coordination number 4, I have two cases. One is tetrahedral geometry. Tetrahedral geometry anta barutte. We have seen last slides session alli maatadidivi. Or another one is square planar. Hauda? Square planar geometry. Square planar geometry. So tetrahedral geometry, in this case, all four ligands are symmetrical and arranged with respect to one another. As such, geometrical isomerism is not possible. ಹಂಗಿದ್ದಾಗ it is not possible. Therefore, we never speak about this. Square planar geometry alli, the four ligands occupy the positions at four corners and the metal atom at the center or ion is at the center and lie in the same plane. Planes change agala, one above, one below agala. They all lie in the same plane. So let us try to understand this by taking an example here. So square planar complex ತಗೊಳ್ಬೇಕಂದ್ರೆ, so I will take the example. We have types also here. Let me write the type. The type comes out to be M-A2-B2. What does this mean? M stands for metal atom. So metal atom nanu, I will take it as platinum. A2, A is my one type of ligand, B is another type. So A I will take it as chlorine, B I will take it as NH3. Let us see. So molecular formula yenagatte heli. Molecular formula comes out to be PT NH3 twice Cl twice. Howda? This is the molecular formula. So hege arrangement ಮಾಡ್ತೀವಿ ನಾವು? How the arrangement is been done? At the center you have the metal atom. So here we have arrangement. So let us see. So I have to make four ligands positions ಕೊಡ್ಬೇಕು. So I'll write it like this. Cl, Cl, and here I'll write NH3, NH3. Or I can write it like this also. You can see here platinum. I'll mention it here. So Cl, Cl, here NH3, NH3, NH3. So here this is where they are lying near to each other. Howda? So what type of isomerism is this? Near to each other andaga, this is cis isomer. And you can see it is slightly pale yellow in color. It is slightly pale yellow in color. Near to each other. The two identical ligands are near to each other. Whereas here the two identical ligands are opposite. Howda? So this is what? This is trans isomer. And if you see the color of this particular compound, it is intense yellow, or you can say dark yellow in color. Yes. So this is the type of cis trans isomerism when the coordination number is 4. Now, if I talk about cis trans isomerism in coordination number 6, 6 iddaga geometry bandbittu octahedral geometry agatte. We have octahedral geometry. Okay. So octahedral geometry iddaga, what will be the positions? I can tell you cis positions, trans positions. Octahedral, 6 ligands will be attached to the central metal atom. Fine. So 6 ligands hang attached irutte. If you want cis positions, please remember this like this. This becomes easy. Cis positions yavavappa? The cis positions are, I'll make it in a better form. Cis positions are 1, 2 form is cis position, 2, 3 form is cis position, 3, 4 form is cis position, 4, 5 form is cis position, 5, 6 form is cis position. Yes, if I'm talking about trans, ಅಂದ್ರೆ 1, 2 ಅಲ್ಲಿ ಸೇಮ್, 2, 3 ಅಲ್ಲಿ ಸೇಮ್, 3, 4 ಅಲ್ಲಿ ಸೇಮ್, 4, 5 ಅಲ್ಲಿ ಸೇಮ್ ಲಿಗ್ಯಾಂಡ್ ಇದ್ದಾಗ ವಿ ಕಾಲ್ ಇಟ್ ಅಸ್ ಸಿಸ್. ಟ್ರಾನ್ಸ್ ಅಂತ ಅಂದ್ರೆ ಟ್ರಾನ್ಸ್ಪೊಸಿಷನ್ಸ್ ಯಾವ್ಯಾವಪ್ಪ? ವೆನ್ ವಿ ಟಾಕ್ ಅಪೋಸಿಟ್ ಆಗಿರ್ಬೇಕು. ಎಸ್, ಸೊ ವಾಟ್ ಆರ್ ಟ್ರಾನ್ಸ್ಪೊಸಿಷನ್ಸ್? ಸೊ ಟ್ರಾನ್ಸ್ಪೊಸಿಷನ್ಸ್ ಬಂದ್ಬಿಟ್ಟು ಇಟ್ ಈಸ್ 1, 4 ಟ್ರಾನ್ಸ್ 1, 4. ಹೌದಾ? ಸೊ ಐ ಕ್ಯಾನ್ ಶೋ ಯು ಬೈ ದ ಸ್ಟ್ರಕ್ಚರ್ ಆಲ್ಸೋ. 2, 5 or 3, 6 ಅಂದ್ರೆ similar ligands if they are at 1 and 4 position, if they are at 2 and 5 position, if they are at 3 and 6 position, then it is a trans isomer. Let us see it with an example. Here, see, this is my central metal atom. So I'll write here positions, draw madona. So what are the positions ಪೈಲ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಹೌದಾ? So this is 1 at the top, 1 at the bottom. Tetrahedral geometry. So let me start numbering 1, 2, 3, 4, 5 and 6. Okay. So here I have octahedral geometry. Correct? So this is my octahedral geometry. ಇದನ್ನ join ಮಾಡ್ಬಿಟ್ರೆ you'll get octahedral, one above and one below. So cis positions ಯಾವ ಹೇಳಿ? Cis positions 1, 2, 2, 3 ಅಂದ್ರೆ two similar ligands at 1 and 2 position, two similar ligands at 2 and 3 position, two similar ligands at 3 and 4, 4 and 5, 5 and 6 is cis isomer. But my two similar ligands, for example, say chlorine atoms, two chloride ions, one is at one position and another one is at 4 position. ಹಿಂಗಿದ್ದಾಗ ಹಿಂಗಿತ್ತಪ್ಪ 1, 2 ಇತ್ತು ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ 6, 1, 4 ಇತ್ತಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಟ್ರಾನ್ಸ್, ಅಥವಾ 2, 5 ಇತ್ತಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಟ್ರಾನ್ಸ್, 3, 6 ಇತ್ತಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ ಟ್ರಾನ್ಸ್. ಸೊ ದಿಸ್ ಇಸ್ one of the isomerisms in case where coordination number is 6 and the geometry will be octahedral. You can take it with an example also. I'll write here. I have many types here. First one is type 1, let me say, where the compound is Ma4B2. Then you have type 2, where the compound will be of form Ma3B3. And then you have a type 3, where the compound will be of the type M into the bracket, square bracket. It will be M AA2B2 plus 2 ion. So this can be the possible types. ಹೇಗಪ್ಪ, I'll tell you examples also here. ಯಾವ್ಯಾವ examples ಬರುತ್ತೆ ನೋಡಿ. M ಅಂದ್ರೆ metal atom, AB ಅಂದ್ರೆ these are types of ligands. Different ligands ಆಗಿದೆ ಅಂತ ಅರ್ಥ. So here the example ಬಂದ್ಬಿಟ್ಟು I can write metal atom as CO, then I can type A as NH3 4 times, and B can be taken as Cl2. So this is Ma4B2 type. If I talk about Ma3B3, then I will write M as RH. Yes, RH. A is my, let me say, Cl 3 times, and B is Py 3 times. Yes, so this is my type 3. MAA2. AA ಅಂತಂದ್ರೆ two donor sites are there. ಅಂದ್ರೆ ಯಾವ type of ligand ಹೇಳಿ? It is a bidentate ligand. So there I can write a CO metal atom, and AA can be taken as CH2NH2 twice, the whole twice. ಹೌದಾ? CH2NH2. That is CH2NH2, or let me place it like this in a better way to understand. CONH2, I'll write it here. CH2NH2, CH2NH2. So you can see here two bidentate ligand ಇದೆ ಇದು. It is having two donor sites. And then B2 can be taken as Cl2 plus 2. So these are the examples for different types where octahedral complexes are seen. So here I can write the structure for type 1 also. Cobalt is at the center. Howda? Then here I have, ನೀವೇ ಹೇಳ್ಬೋದು immediately after looking which is cis and which is trans. So I'll write here Cl, then remaining 4 NH3 ಅಲ್ಲ. So NH3 and NH3. So this is cis or trans? Come on, tell me. This is cis isomer. It is cis isomer. And the color, if you see, it is blue violet. Okay, take the another one. I can also represent it as CO, octahedral geometry. So I can write it as Cl here, 1 and 4 position, and then all 3 NH3s here, 4 NH3s here. So see what type of isomerism it is. It is trans isomerism, and its color, if you see, it is not blue violet, it is green. So this is trans isomer, which is green in color. Getting my point? So 1-4 position. E positions ನೆನ್ಪಿಟ್ಕೊಂಡ್ಬಿಡಿ for coordination number 6 octahedral geometry ಇದ್ದಾಗ this is how we write. Okay, 1 starting here, 1 2 3 4 5 6 ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Cis positions ಅಂತಂದ್ರೆ ಯಾವುದನ್ನ ನಾವು cis isomer ಅಂತೀವಿ? When there are similar ligands at 1 2 2 3 3 4 4 5 or 5 6 positions. ಟ್ರಾನ್ಸ್ ಯಾವಾಗ ಅಂತೀವಿ? when 1 4 position ಅಲ್ಲಿ ಸಿಮಿಲರ್ ಇದೆ, ಅಥವಾ 2 5 position ಅಲ್ಲಿ ಸಿಮಿಲರ್ ಇದೆ, ಅಥವಾ 3 6 position ಅಲ್ಲಿ ಸಿಮಿಲರ್ ligand is present andaga we talk about trans isomerism, correct? So and the colors also of the compounds will be different. Coming to the next one, that is optical isomerism. Optical isomerism. Okay, now what does this optical isomerism mean? So optical isomerism andaga, they are what we have seen in organic chemistry also. They are mirror images. Yes, mirror images of each other. They are non-superimposable mirror images of each other. And so I can say mirror images of each other, they are non-superimposable. Mirror images. And when this is possible? This is possible only when the compound is having chiral center. So it is possible only when the compound possesses chiral center. Chiral center means all the attachments should be different. All the attachments to the central metal atom should be different. So mirror images antandre, place your palm in front of the mirror. Suppose illi mirror ide ankolli. So you will get a picture like this. Now take this. This is the mirror image. Howda? Now take this and put it on this. Will it coincide? Will the image coincide? See, here is my thumb and here is my little finger. Yes or no? And here is my thumb, here is my little finger. It is not coinciding. That is called non-superimposable mirror images. So this is possible only when all the ligands attached are different. Athwa some cases, some of the things might be same. So it should possess one or more chiral centers. Central metal atom should be chiral. And the third condition is they have similar physical and chemical properties. Similar physical and chemical properties, but differ in rotating the plane polarized light. Rotating the plane polarized light. They differ in rotating the plane polarized light. Plane polarized light anta andre ಏನು ಅಂತ ಹೇಳೋ ಅವಶ್ಯಕತೆ ನಿಮಗಿಲ್ಲ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ, because PU1 ಅಲ್ಲಿ in the previous sessions you have already studied. So when you pass it through a nickel prism, so the light which is vibrating in all the directions, it is main monochromatic light. It will be vibrating in only one particular direction. ಅದನ್ನ ನೀವು solutions ಅಲ್ಲಿ pass ಮಾಡಿದ್ರೆ either it will rotate to the right side, it will rotate to the left side. ಅದರ ಮೇಲೆ ನಾವು ಡೆಕ್ಸ್ಟ್ರೋ ರೊಟೇಟರಿ ಮತ್ತು ಲಿವೋ ರೊಟೇಟರಿ ಅಂತ ಅಂತೀವಿ, ಹೌದಾ? ಸೊ ಆ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ ಲೈಟ್ ಫಿಸಿಕಲ್ ಮತ್ತು ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಸೇಮ್ ಆಗಿರುತ್ತೆ, ಬಟ್ ದೇ ಡಿಫರ್ ಇನ್ ವಾಟ್? ದೇ ಡಿಫರ್ ಇನ್ ರೊಟೇಟಿಂಗ್ ದಟ್ ಪ್ಲೇನ್ ಪೋಲರೈಸ್ ಲೈಟ್. If it is rotating to right side, if it is rotating to left side, the isomers arise and we call them as optical isomers. ಏನಪ್ಪ rotating the plane polarized light? Isomers which rotate plane polarized light. Isomers which rotate plane polarized light to the right are called dextrorotatory. D form. ಹೌದಾ? ಅಥವಾ sometimes we write it as plus also. Okay. And the isomers which rotate plane polarized light to the right side, to the left side, to the left side. They are called levorotatory. And they are written as L form or in some cases indicated by negative sign also. So this is the explanation regarding optical isomerism. This optical isomerism can be understood by taking various examples also. So let us see one by one. So let me consider I have a type M A2 B2 C2. I have this particular and N plus or minus it will be. Okay, N plus or minus. Plus charge ಇರ್ಬೋದು ಅಂದ್ರೆ complex ion can be cation or a complex ion can be anion also. So let me take an example here. Platinum Py2 NH3 2 and Cl2. Cl2 and the charge is plus 2. So I can write here the central metal atom is my platinum. Correct? Okay, and here I have 6 coordination number. So octahedral geometry, I'll write it like this. Py, NH3, NH3, Cl, Cl. So this is my compound and it is rotating the plane polarized right to the right side. So this becomes D isomer. Itardu mirror image bariri nodana. If I place a mirror here, I'm sorry. If we place a mirror here, so write the mirror image. So let us say we have a mirror here, correct? So what will be the mirror image of it? So mirror image, see, you are placing it in front of a mirror. Andaga, what do you get it as a mirror image? So here we have Py, here we have NH3. Top doesn't change, Py. Bottom also doesn't change, NH3. Cl, Cl. This is L isomer, athwa L form anta anbodu. Look at the cases. Both are having 1, 2 positions, same ligands, 3, 4 positions, same ligands, 5, 6 positions, same ligands. Here, 2, 3 positions, same, 3, 4, same ligands are there. So this is what? This is both are cis isomers. These are cis isomers. This is D isomer and this is L isomer. Yes. Similarly, we can take one more example. The compound banbitu, it will be M, A, B, C, D, E and F. Andre, all the 6 ligands are different. So let me write an example here. I'll take metal atom as platinum. So one ligand is Py, another ligand is NH3. Then we have NO2. Then we have Cl. Then we have Br. Okay, so this is my ligand. It's a neutral complex anta anbodu. So let me write the structure for it. Pt at the center. So here we have 6 ligands showing the octahedral geometry. I'm not drawing the geometry. Okay, so this is 1, 2, 3, 4, 5, 6 positions. So I'll start it like this. Br, NO2, NH3, however you want, you can write because all 6 are different. Doesn't make much difference. Cl and Py. So Py illinda start ಮಾಡಿ ಬರಿಬಹುದು ನೀವು. Okay. So let me say this is my D isomer which is rotating the plane polarized light to the right side. Fine. Now if I place a mirror here, what will be the mirror image? What will be the mirror image? Yes, come on, tell me. Yes, write the mirror image. So here we have PT. Then here comes NO2, here comes NH3, up is Br, at the bottom we have I, this side. Okay, Br and Cl is being taken, ala? Fine, let us take it Cl only. So here Cl is also there. Then which is the different one which we had taken? Py, NH3, NO2, Cl, Br. 1, 2, 3, 4, 5. Okay, we need one more. Therefore, here I can take Br and I also. Fine. 1, 2, 3, 4, 5, 6. Okay. So here I have I and here Py and this is Cl. So this is the mirror image. Therefore, non-superimposable. Therefore, it is L isomer which rotates the plane polarized light to the left. L isomer. ಅಥವಾ ನೀವು ಇದಕ್ಕೆ ಪ್ಲಸ್ ಐಸೋಮರ್ ಅಂತಾನು ಬರಿಬಹುದು, ಇದಕ್ಕೆ ಮೈನಸ್ ಐಸೋಮರ್ ಅಂತಾನು ಬರಿಬಹುದು. Signs are just the conventions to say whether it is at the right side or at the left side. Plus sign ಅಂತಂದ್ರೆ right side, minus sign ಅಂತಂದ್ರೆ left side. Take another example. I'm taking a typical example. Now you can see here it is MAA3 N plus or minus. AA means I am talking about a bidentate ligand. So I'll take M metal atom ಏನಂತ ತಗೊಳ್ಳೋಣ. I'll take it as cobalt. Fine. So cobalt, AA bidentate ligand En, ethylene diamine, and the charge is +3. So let us see how we can write. Okay, in the center is the metal atom, that is cobalt. Here octahedral geometry ne ಹಾಕೊಂಡ್ ಬಿಡ್ಬೇಕು. So we have octahedral geometry. En is a bidentate ligand, therefore point of attachment ಹೆಂಗಿರತ್ತೆ ಹೇಳಿ? It will have two donor sites. ಹೌದಾ? Bidentate ligand ಅಂದ್ರೆ it will have two donor sites. So here ಇವೆರಡು donor sites ತಗೊಂಡ್ಬಿಟ್ಟು I can write it as En. I can take this two donor sites, I can write it as En. Here these two donor sites, I can write it as En. Andre what I'm trying to tell here is ethylene diamine ಅಲ್ಲ. So NH2 CH2 and here CH2 NH2. Instead of writing all this picture, I've just shown it like this. And this either the complete charge ಬಂದ್ಬಿಟ್ಟು +3. You should show it like this. Fine. Now if I write the mirror image of this, ಹೇಗೆ ಬರುತ್ತೆ ಹೇಳಿ mirror image? So write the mirror image. Cobalt at the center. ಅರ್ಥ ಆಯ್ತಲ್ಲ what I'm trying to say? ಇಷ್ಟು ಬರೆಯೋ ಬದಲು I have made just a circle. Okay. Ligating chelating ligand ಅಂತ ನೋಡಿದೀವಲ್ವಾ? So here chelating ligand ಬಂದ್ಬಿಟ್ಟು, so ಅದನ್ನ I have shown it in that form, particular form ಅಷ್ಟೇ. So here these two donor sites En, these two donor sites En, and these two donor sites will be taken by En. So this is D form ಅಂತ ಅನ್ಬೋದು, D form, and this is L form. Correct? So mirror images. So that is about the example where we have bidentate ligand. One more example I can take where I will have the type MAA2AB. AB andre athwa let me make it simple. AA2 ಮಾಡ್ಕೊಂಡ್ ಬಿಡೋಣ. And then we will see AB. Okay. So this is A2 and here N can be plus or minus charge. So metal atom CO, En twice, Cl twice. Correct? Howda? So write the mirror image, write the images. So CO at the center, octahedral geometry. Show the octahedral geometry. Okay, fine. So here I'll write Cl, here I'll write Cl. This will be taken by ethylene diamine and this will be taken by ethylene diamine. So this is D form anta anbodu. And since they are similar positions ನೋಡ್ಬಿಟ್ಟು you can say cis D form. Now place the mirror image. Mirror you place and write the mirror image for this. So mirror image ಬಂದ್ಬಿಟ್ಟು ಏನಾಗುತ್ತೆ ಹೇಳಿ? So mirror image will be CO here, Cl, here we have En, and here we have En. Yes, so this is also cis, but it is L form, rotates the plane polarized right towards the left side. One last example where we'll be taking AA2 bidentate ligand and AB. Three different ligands we are talking about. So example ಬಂದ್ಬಿಟ್ಟು CO, En twice, NH3 and Cl. Yes, +2. So N plus or minus it may be. So bariri nodona, write the isomers. So CO at the center. So here we have octahedral geometry. Now I'll write here En. I'll write here En. And here will be NH3 and here will be Cl. So this is what? This is D form. D form howdu? Rotates the plane polarized to the right. So here it is similar ligands. Therefore I can write it as cis D form. Okay. Place the mirror image. Mirror place madi and write the image. See what do you get? So here it is CO. cobalt, central metal atom. Then here we have this. This will come like this, mirror image, ala? And here we have this En, here NH3, and here Cl, charge barbito plus 2. I'll write charge here. Here also I'll write the charge plus 2. So like this we can write this charge. This is also cis because same, but it is L form. That is rotates the plane polarized right to the left side. So this is all about the different types of isomers, what we have discussed. Structural isomerism ಆಗಿರ್ಬೋದು, stereo isomerism ಆಗಿರ್ಬೋದು, and under stereo isomerism we have seen the types. Under structural isomerism we have seen the different types. So geometrical isomerism ನೋಡಿದೀವಿ. So we have taken different examples of different types ನೋಡಿದೀವಿ. 6 coordination number ನೋಡಿದೀವಿ. Same example we have taken. Yes, then optical isomerism, I said mirror images of each other. Place the mirror, you will get different structure. Other stereoisomers called optical isomers or enantiomers also, they are mirror images, just like your hands. Yes, they cannot be superimposed. They are non-superimposable mirror images. And with coordination number 6, Nodidivi, with the octahedral geometry, we can take examples of monodentate ligands, bidentate ligands. You will get different examples. Structural isomerism, we have seen ionization isomerism, linkage isomerism, when you have nitro, see, ambidentate ligand idaga, you get different. Here N is the point of attachment to central metal atom. Here O is the point of attachment to the central metal atom. Coordination isomerism, both are complex ions, complex cation, complex anion. Hangidaga, exchange of the ligands, interchange of the ligands between the complex ions takes place. Then we have hydrate isomerism, water molecules, number of water molecules as the ligands differ. So in the first case, all 6 are water molecules. Second case, there are 5 water molecules. Third case, there are 4 water molecules as ligands. Remaining are outside. That is hydrate isomerism. So this is all about the isomerism and the different types we have studied. Hope you have followed this. In the next session, we'll be covering up entire part of coordination chemistry. That is, we'll be talking about Werner's theory. We'll be talking about crystal field theory. We'll be talking about valence bond theory and many theories, what all we'll be discussing in the next session. For now, I hope you have understood all the concepts. Thank you once again.